children, how are you all? I hope all you are fine. Children, in that previous video we discussed that worksheet 3, right? In this video we are going to discuss about that concept 4, which is related to properties of rational numbers. Okay ma, what is that? Properties of rational numbers. Hi children, how are you all? I hope all you are fine. Children, in that previous video we discussed that worksheet 3, right? In this video we are going to discuss about that concept 4, which is related to properties of rational numbers. What is that ma? Properties of rational numbers. Properties of rational numbers. What properties are there? Okay, what type of properties are there? The first one is closure property. Already you learnt about this one on the 10 natural numbers, whole numbers, like that properties there, no ma. So like that only to the rational numbers also we have some properties. What are those? Closure property, commutative property, associative property, fourth one distributive property, okay. After this one we have that additive identity. Additive identity is nothing but a role of 0. Additive identity, additive inverse, next one multiplicative identity, and in the same way multiplicative inverse, yes, these are the properties. Okay ma, these all are the properties of rational numbers. Here we have to check that. See, closure property, commutative property, associative property, distributive property, these all comes under that. Here 4 fundamental operations also we have to apply. Okay, 4 fundamental operations also we have applied under that closure property, commutative property, associative property, and here come to the distributive property. Here addition, over addition we will discuss about that. Now here see that closure property, commutative property and associative property, on that 4 fundamental operations also we have to discuss. Okay ma. Now what about that closure property? Okay, first one, what is that? Closure property. See here. Come to the closure property. Here what is that statement means? Here A by B and C by D. Let A by B and C by D are any 2 rational numbers. Okay, what are those ma? Let A by B and C by D are any 2 rational numbers. Are any 2 rational numbers then A by B star C by D is also a rational number. Is also a rational number. Okay, once again see that what is that ma? Let A by B and C by D are any 2 rational numbers, and here A by B star C by D is also a rational number. Here what about that star? Star represents here any fundamental operation. Star be any fundamental operation. How many fundamental operations are there? 4 fundamental operations are there, right? So at the place of star, here we have to apply that 4 fundamental operations also. Okay, first we have to apply that addition, subtraction, multiplication, division. So that's why here let star be any fundamental operation. Okay, which means here at the place of star we have to take that addition, subtraction, multiplication, division. Clear ma? Those 4 symbols also we have to apply. Okay, so first under that addition, one see that let A by B and C by D are any two rational numbers, and here A by B star C by D is also a rational number. Then only we can say that rational numbers are closed under addition. Okay, once again see here, let A by B is equals to 1 by 2 and C by D is equals to 3 by 2. Let it be some these two rational numbers I taken here. Once see that A by B, C by D, 1 by 2, 3 by 2. Okay. Now here A by B is a rational number, and in the same way here A by B and C by D, those two also belongs to rational numbers only, no? Okay. Now here A by B plus C by D, which is equals to A by B means 1 by 2 plus C by D is equals to 3 by 2. Then what we will get here? Just to say that those two also having that same denominators, no? That's why here in the denominator again we will get that same denominator. That one is 2. Just add that numerators 1 plus 3, which is equals to 4 by 2. 2 ones, 2 twos. After cancellation, how much we got here? After cancellation we got it as 2. 2 is a rational number or not? Yes, here 2 is a rational number. 2 belongs to rational number. See that as per the definition what they are saying ma, A by B 1 by 2 is a rational number, C by D 3 by 2 is a rational number. If you combine those two, if you add those two rational numbers, the resultant what we got here, that one is also a rational number. Yes or no? Yes, here that one also we got it as a rational number. 2 is also a rational number, no? So that's why here what we can state here, that's why rational numbers are closure property, no ma, that's why here are closed under. Okay, this is the property name, closed under addition. Closed under addition. So here you can take that positive rational numbers or negative rational numbers, whatever it may be. If you will take that any two rational numbers, one is positive, one is negative, or whatever it may be, those two are positive, those two are negative. Okay, whatever you will take, but here the addition of rational numbers are closed under addition. Understood ma? Yes. Now come to that subtraction. What is that next fundamental operation ma? Subtraction. Okay. Now here say that in subtraction what is that statement here? Let A by B is equals to, again I want to take that 1 by 5 and C by D is equals to 3 by 5. Then here subtraction, no? So what is the symbol of subtraction here? A by B minus C by D. Okay, this value we need to find out, no? Okay, actually as per that definition, A by B, if A by B is a rational number, C by D is a rational number, then A by B minus C by D is also a rational number. Then only here rational numbers are closed under subtraction. Otherwise not closed under subtraction. Okay ma. And here come to that. Here let A and B are any two natural numbers, then subtraction is not possible. Okay. Why? Because those two are natural numbers. At that case we may get that negative numbers also, no? That's why at that cases we will tell that here natural numbers are not closed under subtraction. Whole numbers are not closed under subtraction. Okay. Integers are closed under subtraction. Okay, integers are closed under subtraction, and here rational numbers also closed under subtraction. Why? Because if you subtract any two rational numbers, you may get that positive rational number or negative rational number, or sometimes you may get 0. Okay, these all numbers are comes under that rational numbers only, no? That's why here rational numbers are closed under subtraction also. Once say that A by B minus C by D. A by B means 1 by 5 minus C by D means 3 by 5. Okay. Now here in the denominator what you will get ma? Again those two also having that same denominator, no? So that's why write here 5. Just take the difference of its numerators, 1 minus 3. 1 minus 3 is equal to how much you will get? Just you have to take the difference of 3 and 1, and what the largest number has the sign, that sign you have to keep. 3 minus 1, 2, and the largest number having the sign minus, that's why minus 2 by 5. Now here see that a by b, 1 by 5 belongs to rational number, 3 by 5 belongs to rational number, and in the same way 1 by 5 minus 3 by 5, we got here minus 2 by 5. Now here minus 2 by 5 is belongs to rational number or not? Yes, that is a rational number, negative rational number. That is a negative or positive, whatever it may be, that is a rational number or not, that's what we have to see. Understood, ma? Yes, see here. So that's why here that condition also satisfying, no? That's why what we have to write here. Therefore, rational numbers are closed under subtraction, closed under addition, and closed under subtraction also possible. Closed under subtraction. Clear, ma? Yes. Next one we are having that what is the third fundamental operation? That is multiplication. What is that, ma? Multiplication. In that multiplication, again take that statement. What is that? Let a by b. A by b is a rational number, c by d is a rational number. Now, a by b into c by d is also a rational number. Then only here rational numbers are closed under multiplication. Otherwise, the rational numbers are not closed under multiplication. And in the previous also we observed that for the natural numbers and whole numbers, what property satisfies that addition, the same property satisfies for that multiplication also. Okay. Now here see that. Let a by b is equals to 2 by 3, that is a rational number. C by d is equals to 4 by 6, that is also a rational number. Okay. Then a by b into c by d, which is equals to 2 by 3 into 4 by 6. Any cancellations possible, ma? Of course, cancellations possible. Where we are having, see here, 2 1s, 2 3s, 3 1s, 3 2s. Again, we will get here 2 by 3. 2 by 3 is a rational number or not? Yes, here 2 by 3 is a rational number, 4 by 6 is a rational number. After taking the multiplication, the product is also a rational number. The product what we got here, that is also a rational number. That's why what we can say here, ma? Rational numbers are closed under multiplication. Closed under multiplication. Am I clear to you? Okay. So here this is satisfies under that multiplication also. Next, what is that last fundamental operation, ma? Division. Okay. Fourth fundamental operation, division. Now check for the division. Let a by b is equals to 4. That is a rational number or not? Of course, 4 is a rational number, 4 by 1. Okay, 4 is a rational number. C by d is equals to 1 by 2. That is also a rational number. Then, what is that statement here? A by b division, no, a by b divisible by c by d. That is also a rational number or not, just we have to check it. Okay. A by b is equal to 4. We can write this one as a 4 by 1 also, no. 4 is an integer, that one we can consider it as 4 by 1. Okay. Divided by c by d is equal to 1 by 2. Understood, ma? Now here 4 by 1 by 1 by 2, which is equals to 4 by 1 into 1 by 2 become as 2 by 1. It's a reciprocal only, no? Okay. Now that one become as multiplication. Just take the product of numerators and take the product of denominators. 4 2s 8, by 1 into 1 is equal to 1. Again you will get it as 8 by 1 means 8 only, no, belongs to rational number. So see here ma, if the denominator is not equals to 0, okay, denominator is not equal to 0, then only this one satisfies. Okay, see that. If a rational number p by q, if a rational number p by q, q not equal to 0, then only, okay, q not equal to 0, then only rational numbers are, then only rational numbers are closed under division. Closed under division. Okay. If q is equal to 0, then rational numbers are not closed under, rational numbers are not closed under division. Did you understand this one ma? Why? Because if the denominator is equals to 0, then here that value is equals to undefined. At that cases here we can't say that that is a rational number. Okay ma? Why? Because we will get that one as undefined value, right? So that's why here if a rational number p by q, q not equal to 0, then only here rational numbers are closed under division. Otherwise, if that q is equal to 0, at that cases rational numbers are not closed under division. Why? Because at that cases that is not a rational number. Understood ma? That's why here see that. As per this one, what we can say here? Rational numbers are closed under addition, subtraction, multiplication, division. At the case of division, q not equal to 0, then only here rational numbers are closed under division. Am I clear to you ma? So this is related to closed property. Okay, closure property or closed property. Closure property of rational numbers under addition, subtraction, multiplication and division. Okay, in that next video we will discuss about that commutative property and associative property. Okay, thank you all.